Okay, so the first thing I'm going to do, I'm going to put an acronym over here. Right? Your graph has to be fair. Means first you have to factor it. Right? If I'm going to be able to grade it, you're going to have to make your graph fair. Means first you factor it. Second, you put your asymptotes on the graph. Third, you put your intercepts on the graph. And the last part has to do with regions. And that would be which region are you actually drawing the graph in. Okay, so let's go in order. Factor. Okay, and I notice that it reduces right here, and I'm going to be left with x minus 4, that's a 2, x minus 2. Okay, so I've got my factors, check. I've got my asymptotes, my vertical asymptotes. Now I'm going to label right here. This is the vertical asymptote because that's the factor of the denominator. This is the whole because that's the factor that reduced. This is the x-intercept because it's the factor of the numerator. How do you find x-intercepts of a polynomial? You factor it and set each factor to 0. But just the numerator zeros. Okay, so I have those things labeled. This right here, this is what I'm trying to graph. Yes?
Wait, so I did -4 and +2 for the...
But it adds to +2, so the bore's got to be bigger.
for the factoring of the...
Denominator?
Yeah.
Yeah, I'm telling you it has to be +4 minus 2 because you have to add to +2.
Oh, that's
Yeah.
How can there be an x-intercept because the asymptote is on?
The x-intercept is going to be +4.
That I got the asymptote is on.
No. See here, let's keep going, and I will work out the algebra that shows you solving for it. Okay, so let's put on our asymptote. So that's at +2. Okay. All right, so I've got my x equals +2. Now my horizontal asymptote. Maybe I put it in transformation form to figure out the a, h, and k. Okay. 1, -4. -2. So this gives me 1 plus -2. Okay, so I could rearrange this. Okay, so my k is +1. What we were getting at is I can sometimes just look at that ratio of the leading terms to figure out the horizontal asymptote. Notice x over x reduces to 1. My k value is 1. Okay, slant asymptote, none. These things are in the same category, right? You can't have both. It's one or the other. X-intercepts. Okay, so it doesn't matter which form you use to solve for the x-intercept, and so I will solve for it. I'm going to take the red box. 0 equals x minus 4 over x minus 2. And I'm going to cross multiply. But 0 times x minus 2 is 0. 1 times x minus 4. So I get +4. Okay, y-intercept. I'm going to plug in 0 for x. +2. If they are listed, right, x-intercepts are a point, give me both coordinates, x and y. Okay, the whole. Well, the whole is occurring at -4. The whole is a point. It's a point. It's just like an x or y intercept. It's a point. So if I have x equals -4, -8 over -6 is 8/6, which is 4/3. Okay, so now I'm going to take all of those things and I'm going to try to put them on my graph. Positive 1. Okay. Y equals 1. X equals negative 2. And points. 4, 0, 0, 2. Negative 4, negative 4 thirds. Oh. Too quick. Too quick. Missing whiteout. Oh no. The horror. Wait. Got it. Too quick. Too quick. A hole is an open point. Now you only need 1 point per branch. If you need more points, you plug in and make a table of values, whether you do the reciprocal parent points, okay, or you plug in and actually find points. It's the parent function, guys. One vertical, one horizontal, transformation form. This happens to be the parent with a reflect and a negative 2 stretch.
How do you tell if the whole occurs at like 1 1/2?
Because I plugged in and I got 4 thirds, which is 1.3, so just above the asymptote. It's hard to draw the fraction points appropriately, but I do know it's more than 1 and less than 2. Okay, so I'm going to connect my dots, and I'm going to use my asymptotes as guidelines. I am only looking for 1 point per branch. That's it. Yes. You should draw them. Yes. Because mostly listing these coordinates up here, that's more just so that I can tell what they are on your graph. So the points, which aren't necessarily all integers, so I can see them. But I should be able to say graph this and have only a graph there. Means all I'm doing is grading the graph. What would I check for? Asymptotes and intercepts. So notice regions. Regions is where did you put it? Top left, bottom right. That's where I put the graph. Make sure it's graphed in the correct sections. Okay, so we factored. We did asymptotes. We did intercepts. And then I actually drew the graph. Okay, let's turn it over. All right. Fair. Has to be fair. So I'm going to factor it and take the 3 out. Okay, factored. Oh, this one says transformation form, but I'm just going to go down the list. Asymptotes. Okay, asymptotes. I see this doesn't reduce, so this is a vertical asymptote. This one's going to be the x-intercept, and there's going to be no holes. There's no factor that reduces, there's no holes. All right, x equals 4. Y equals 3. None. These things are a category. It's one or the other. Okay. Intercepts. Okay. 0 equals. I'm showing you the algebra, so I cross multiply. Notice that it turns in just a polynomial of the numerator, which is why the numerator factors give you x-intercepts. Y-intercept. Notice that I'm going to go back to the unfactored version to do the y-intercept. 3/2. 3/2. Okay. Put it all on the graph. I'm going to do, all right, I don't need transformation form yet, right? I'll get there. Okay. X equals 4. The asymptotes are useful as guidelines. Okay. 2, 0. 0, 1.5. Okay. Now, factored, asymptotes, intercepts, regions. Regions mean where are you putting the graph. Now, this is a parent function. So if I'm in bottom left, I have to be in top right, right? They're opposite regions. They're diagonal regions when you have the parent function. So it's going to be the top right. And let's say you're not convinced about it being in the top right. Then put it in transformation form and look at it. Okay, so we have 3x minus 6 divided, so 3 negative 6. Okay, oh no, it just looks better if I put it in this order. Okay, so that's right 4 up 3, looks good, right 4 up 3, 6. 1, 1, 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6, 1. You can also, right, add those points here. You only need 1 point per region. I just counted the 6 everywhere. Give myself a little extra to draw it. Bottom left, top right. What we looked at maybe 2 classes ago or 1 class ago is we went from transformation form to standard form. And one of the conclusions we are looking for is the connection between standard form and transformation form and the horizontal asymptote. This is a practice that we did in the last class. And we noticed that the ratio of the leading terms matched the k value. 2x over x reduces to 2. Look at my horizontal asymptote. 3x over x reduces to 3. And so what I want to do today is talk about how to find your horizontal asymptote without changing it to standard form, right? I'd like to avoid that extra step if I don't need it. And so that's what we're going to do, is we're going to come over here and we're going to fill out our end behavior model, okay, from standard form. Now, end behavior is actually the horizontal asymptote, okay? The big category is end behavior. Within end behavior, you have polynomials, up, down, up, down, up. The other category is horizontal asymptotes, okay? So end behavior model is the top. We have polynomial end behavior. That's where you get all the combinations of up and down. Right? You can pair it any way you want. Polynomial end behavior. Those are your arrows. Up, down, up, down, up. This is it. That's polynomials, remember? Okay? The other category is you get horizontal asymptotes. So basically I'm taking these and I'm adding this. That's all I'm doing. Taking my arrows and I'm adding sideways arrows instead. Different category. Sideways. This happens to be a number. But the big title is end behavior. All we're doing this unit is we're adding a little subset that turns into a horizontal asymptote. But this is the description. This infinity statement, that's the end behavior model. Okay? Now we're going to look at the degree of the numerator, the degree of the denominator. We're going to put a term here, xn. That's the leading term. Because when you look at end behavior of polynomials, you look at the leading term, positive, negative, and the degree. That's all you look at. Well, that's all we're going to look at this time. Except because I have a numerator and denominator, we have to look at both of them and compare them. And so when the numerator degree is less than the denominator degree, so I'm going to give you an example of that. Y equals 1 over x. Okay? Oh, that's the parent function, by the way. That's the parent function. Y equals 1 over x. The numerator degree is 0. The denominator degree is 1. What's the horizontal asymptote of the parent function? 0. Okay? What happens when you plug in 0 or plug in positive infinity here? What's 1 over positive infinity? It's not undefined. How about if I say is approximately? 1 divided, what did you say? 0. 1 divided into infinite number of parts. Take your pie and make infinite slices. How big is each slice? 0. Approximately 0. It is a concept, it's not a number. That is true. That's why we're saying approximately. Okay. Same thing. Well, basically, negative 0. Well, 0 is not really positive or negative. It's just 0. Notice that the end behavior model, because of a number, it actually turns into the horizontal asymptote. It's telling you where the arrows go. The arrows go at the line y equals 0. Okay, so let's do an example of the balanced, or the degrees are equal. Equals a x to the n over b x to the d. Now, that reduces. If n and d are the same, the x's cancel out. How does that reduce? It reduces to this. The horizontal asymptote is just the coefficients, right? That's the rule. Why? Because when you do end behavior, you only look at the leading term. In the leading term, these two pieces cancel it out because the degrees are the same. All you're left with is a over b. Doesn't matter what you plug in. Infinity has disappeared. The x's, the input, disappeared. Just a over b. What does that mean for your end behavior model? You just get a over b. Notice the horizontal asymptote is the end behavior. They are the same thing. Okay. The coolest one. The one you've already learned. The one you already know. Y equals, let's just say x squared over x. Okay, my numerator degree is bigger. Oh, that's how it reduces. Okay. What did it reduce to? X. Okay, give me a category. What's that called? Give it a name. start with an L or a P? What was the title of Unit 4? Oh, it's a polynomial. Oh my God, I'm not in a horizontal asymptote end behavior. I'm in polynomial end behavior because it reduced to a polynomial. That means it's the same end behavior, which means it's going to be the infinities. Oh, well, infinity is not a number. Guess what? That's the slant. That's the slant. It's not a horizontal line anymore. It's a diagonal line, right? I have to point at infinity instead of the horizontal line. So this is no horizontal asymptote. Good catch. Hold on. Check in. Okay, so polynomial end behavior. It turns into polynomial end behavior instead. Okay. This thing has two names. We call this either slant or oblique. And it depends upon which book you look up. I'm going to use the word slant. Okay, right? You saw in the warm-up I titled it slant. That's what I'm going to call it, but it's also called oblique. It just means not horizontal. That's what it is, not horizontal. When you don't have a horizontal asymptote, you get polynomial end behavior, where the same thing works. That reduced to x, your end behavior would be down, up. That's what it would be, down and then up. Okay. How do you actually find your slant asymptote? All right, so let's find it. End behavior model. We're almost there. Just some practice. Okay. Y equals. Notice I titled it end behavior model. That's the infinity statement. This is your end behavior model. That is not an asymptote. That is just the end behavior model. You have to do something different to find the asymptote. Okay? Well, that reduces to y equals x, which looks like this. That's the end behavior. Negative. Negative, positive, positive. I do expect you to remember polynomial end behavior even though it was Unit 4 and we're in Unit 6. There's a lot of content that gets reused. Yes. No, we're going to, two things, right? End behavior model is very generic, okay? We're actually going to find where that line is. That's the second thing we're going to do. How do I actually find this dotted line, right? We found our horizontal dotted lines. How do I find the slant? Well, in order to find the slant, you actually just do synthetic division. You do the division. It's top heavy. Just divide it. Okay? I'm coming, I see you. Okay? Just do the synthetic division. That was useful when we turned our standard form into transformation form. It's going to be useful again. Question?
So, on the warm-up, what you have for the blank, would you just write that?
No. We're going to actually find the equation also. When you're graphing and checking things, you can just estimate, right? Where should the arrows be? Like if you are matching graphs, that's a good way to match. if I actually want the asymptote, you'll have to find the asymptote. And so I'm going to set up my synthetic division, and we're going to see what happens here. Okay. Oh, it's not exactly AHK. It's not exactly AHK. The parent function doesn't account for all possibilities. It just accounts for the graphs that have a vertical and a horizontal. That's it. That's the only ones that fall into this category. This is a slant asymptote. It's not part of the parent. And so my slant asymptote, it's where the K would have been. It's where the K would have been. It's x plus 4. That is the slant asymptote. I usually abbreviate it SA, but I'll write it. Slant asymptote is where the K would have been. Transformation form is useful for a lot of things, right? That division, easy way to pick out the asymptote. Okay, turn it over. You've got 3 questions to try, right? 3 end behaviors, pick the category, and find it. All right, end behavior. Okay, end behavior means polynomials. Look at the leading terms. All I'm going to do is highlight the leading term because it says end behavior. And I know that I'm supposed to look at the leading terms. And I'm going to label it end behavior model. And I'm going to say y equals. And then I'm just going to reduce it and see what happens. That means that the end behavior model reduces to y equals -4. Why did I cut off the other parts of that function? Because I'm only doing end behavior, which is just the leading terms. And then I'll just go ahead and label this. My end behavior happens to be a horizontal asymptote because the degrees were equal. Sometimes we call that balanced. Helps me remember. Balanced. Okay. I'm going to highlight end behavior. Means I'm only going to look at the leading terms. End behavior model reduces to 1 over x. Oh yeah, that's the parent function. I know that gives me an HA of y equals 0. Sometimes, right, end behavior is the big category. The subset is horizontal asymptote. Okay? End behavior is leading terms only. End behavior model, y equals x squared over x, that reduces. Okay, so that means that this is, if I were to plot my points, right? So negative, negative, positive, positive. Arrows just mean approaching. I mean getting close to. And if I actually wanted the asymptote, this didn't ask for the asymptote, okay? It just asked for the end behavior model, which is the infinity statement. I could find the asymptote. I already know it's a positive sloped line. I already know that part. Okay. 1, 0. Oh yeah, see that missing term? 1, -1. So this gives me y equals 1x minus 1. So the slant asymptote is y equals x minus 1. All right, let's go. Number 10. Fair. Your graph has to be fair. Factor, asymptotes, intercepts, regions. I'm just going to put fair. That's a good order to do. your graph has to be fair. Factor, asymptotes, intercepts, regions. Regions has to do with which section you're drawing your graph in. Okay, so see what you can come up with here. Start by factoring. Maybe I'll give you a choice on your graph. I'll give you 4 and ask you to do 3 on your quiz. Once you pick one. So there's no holes. So there's no holes, but that does tell you 2 intercepts and 1 vertical. So the factors actually just give you a lot of information.
Okay, but so this is a vertical axis.
Yep. X intercept, X intercept.
These are both X intercepts.
And then to find your other asymptotes, you're like, oh, okay, so now I gotta do a little division to find my other asymptotes. Yes, start by factoring.
So x plus 2 and x minus doesn't work.
Because factoring is going to give you the vertical asymptote. It's going to give you the x-intercepts from the
I mean,
numerator.
I knew that, but like, I didn't know what to do.
And then to find the other asymptote, you look at that behavior.
This is the slant.
Yes.
We should just graph this part of the plane.
No, just try to put on what you do have, and then we'll figure out what
And it's your
you
fat slab.
Okay. So I can just graph the.
Yep, just graph the asymptotes.
Oh,
Graph what you
like,
if you don't know the other things, just leave. Graph what you do know and leave the stuff you know. You should be able to put your asymptotes on the graph. Let's go for that. Put your asymptotes on the graph. And then we'll get to the other 2 letters. So put your vertical asymptotes and your slant asymptote on the graph. Put your asymptotes on the graph.
what's it supposed to be? Like this answer right here? Oh, that gives you,
Wait, careful, where there's
Weird. Did you get negative 12?
Vertical is good. The
But yeah,
slant.
otherwise you do that right, that'd be negative 12.
Yeah, okay.
X minus
I
1,
did
X plus.
synthetic division.
Yeah, so you're going to divide it from standard. Yeah.
Because the last one that we used to do was
That's X.
Okay,
Wait,
it
hold
is
on.
this,
said
except you
how
need to
do
figure
that.
out
How to do
exactly
that.
what the intercept
No,
is.
there's a way to do it.
you know, ours needs to be.
Aren't you cheated?
Okay? There is not. It's a slant.
Wait, there's no asymptote? Because it's a slant.
Because it's a slant, yes.
I'm smart.
Oh, so then it's one.
So it's, so we've got 4 regions, I gotta figure out where to put them. Exactly.
Yeah, it's a slant X minus 2.
What? Yeah, dude.
Uh-huh.
Your dad wanted me to like, you should say, we'll get it next time. What did I get?
Okay, almost there. Okay.
Sorry, I got, or not six, I got 12.
Yeah, that's okay.
I know, but like, I can't.
Yeah, I'm gonna, so I'm gonna tell you. Regions is the last thing, like, where do I actually put this? Right? That's a discussion. All right, here we go. Factor. X minus 5, x plus 2, x minus 1. Oh, nothing reduces, so there's no holes. I'm going to label my factors what I get. This one gives me a vertical asymptote. I'm thinking, numerator factors give me an x-intercept. Okay, so I've got the factoring. I need my asymptotes. My vertical asymptote is x equals 1. So I'm going to put x equals 1 on the graph. Okay, x equals 1. Horizontal asymptote. It's top heavy, or the numerator degree is more. There's no horizontal, which means I need to find the slant asymptote. 1, -3, -10. Okay, so my slant asymptote is this. So I'm going to put that on the graph. Right? I'm not even writing the remainder part because I just want the k part. Okay, so at -2 and a 1 slope. I might even just leave this one dotted. It's easier to see that way. Okay, right? There's my slant asymptote. I want to make sure I can see the point, so I'm going to leave it dotted. Oh, okay. Asymptotes, check. Intercepts. Okay, so I have x-intercepts. My x-intercepts are 5, 0, and -2, 0. And y-intercept. Okay? Y-intercept. Let me plot it, and then we'll talk.
Why is the intersection point -1 if the thing at the bottom is negative plus here?
What are you talking about?
If the ratio is 1 to 1, wouldn't it be +1 instead of -1? For the slant asymptote.
No, it's not 1. It's y equals x. Because it's top.
Which why is it -1? Oh. The intersection.
Oh, it doesn't matter where they intersect. No. This is not a parent function anymore because it's not. Parent function is 1 vertical, 1 horizontal. As soon as this slants, it's not a parent anymore.
How do we find out where like what it's on, like what the line is?
Start at -2. Plot a line with slope of 1. Okay? Shh. Y-intercept is -10 over -1, so positive 10. So that's 0, 10. Okay. Regions. Where do you draw the graph? Well, okay. I know what I need. Hold on. It's right here. Okay. Here we go. I'm gonna highlight something on this graph. Hopefully you'll be able to see it. Shh. Okay. This is a parent graph. Okay? That is a parent graph. Your sections, right, they go here and here. Once you slant that asymptote, it is no longer a parent. Okay? Hold on. Let me slant my asymptote. Okay? And what's going to happen is my section of the graph that looked like this, it's just going to squeeze up and fit into the section. It would go like that. Right? All you did is you slanted the asymptote. That section of the graph just stays there. But hold on, wait. Hold on. Look at your points though. So look at your point. You're thinking that the graph should look like this because I have to touch the point. Except that it expands and it has to fit within the section of the graph. So bottom right, look at your point. It's in bottom right. It's in the bottom right section because that's where your point is. You only need 1 point per branch. It's going to tell you where to put it. It's in the bottom right section. Look at your other point. Top left section. Now they're still opposites, right? They're still on the diagonal. Top left, bottom right. And so you're thinking that usually it looks like this. That's usually what it looks like. Well, just expand it, right? Obtuse or acute. This one's going to be an obtuse looking line. Right here. Through the point. All we did is we took that slanted asymptote and we just drew the graph near the asymptote, going through whatever point was already there.
Are we always only going to have one point?
Yes, unless you want, hold up, what does it say? Unless you're like, I don't know what to do, then you can just plug in and do what you want.
How would that work? Like, how would you get those separate points? Because on the parent function, it's really easy because
So
you just count like
you would have to actually make a real table of values because this is no longer a parent.
Yeah.
Means you'd actually have to plug and chug. Points are slow, which is why I'm not showing you how to do it.
Also, this question is kind of like arbitrary, but what if you had like with the like x squared over x? What if you had an x cubed over x? Would you have an asymptote that's like?
We only do a difference of one. It would be a parabolic asymptote. You would draw a dotted, which we're not doing. That's like
Yeah.
I don't even think pre-calc does that. We keep it to a difference of one. Okay, so draw the line, expand it through. Draw, right? Start at your asymptotes. Go through your point towards your asymptote. Yes.
Oh, so since it was x squared over x, it would be y equals x. So that's why there's no horizontal.
Correct.
Okay.
Correct.
So if it was x over x squared, what would the horizontal asymptote? It was
Y equals 0.
y. Okay. Yeah. Okay.
All right, make your graph fair. Right? Start labeling what you can. I really like that acronym. It helps you remember what to do. It's a lot of things.
I'm getting
It's easier once you know more. It just takes 3 days to get everything in there. Okay. All right, so then try the little mini quiz we're going to do next month just to see where you're at, and then we'll go from there. All right, make your graph fair. Start with the factors and asymptotes. We're going to do this. Just start by making your graph fair. This is going to help us with factor, asymptotes, intercepts, and regions. That's how you graph it. Just go here first, right? This number 5 helps us with the regions. There are 2 vertical asymptotes, agreed. Yeah, so there's no x-intercept. Means don't touch the x-axis, right? Yeah. So yes, 2 and 1. And as soon as you move away from this, it's no longer apparent. It means you can't do transformation. As soon as you slant it, it's not apparent. Which means that negative 12 or that 12 we saw does not stretch at all. Okay, as soon as you get to vertical, it's not apparent. Okay, good. Okay, see if you can find intercepts. X-intercept, Y-intercept. There are none, correct. So just write x-intercept none. Okay, remember, polynomial zeros are factors. There are no factors at the top, so none. Because that cross multiply gets rid of the denominator. Okay, good. 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 What about the HA? Okay, what's the leading term of the numerator?
So it just looks like this.
And what's the leading of the denominator?
She wants us to find y.
Which one is bigger? No. Which degree is bigger? So it turns into 1 over x squared, which if you go to infinity, it's basically 1 over... Yeah, so it's basically just this. Anytime the numerator degree is less than, it always turns into 0. Okay. X and Y intercepts. Correct. Okay, so that's good to know. Yes.
Yeah.
So that's why
Okay, here we go. It's like all about to come together here. Factor. Let's shall just put fair down here. Okay. So, eyes up. Shh, quiet. Okay. Factors. Okay, so now I'm going to start labeling. Vertical asymptote, vertical asymptote. There's no factor of the numerator with a variable, guys. A factor with a variable, which means there's not going to be an x-intercept. Okay, so vertical asymptotes, x equals 3. Oh boy, 2 of them. Yes, there's 2 of them. Okay. It's a little squiggly. See if I can move that back over. It's the only problem with using a marker. Sometimes it's a little... Okay. Yeah, you gotta... Right? You have to put them all on there. No, it's on 3. Okay. So, next... HA. All right, so I'm looking at the degree of the numerator is 0. The degree of the denominator is 2. The denominator is bigger, which means it's going to be HA of 0. The degree of the denominator is bigger. So end behavior model gives me 2 over x squared. The denominator degree is 2. That is bigger, which means it is 0. Is the horizontal asymptote. Okay, factor, asymptotes, intercepts. X-intercepts. You end up with, right, just numerator factors, guys. Numerator factors. So that's none. Y-intercept. Okay, so 0, negative 2/9. That's barely here. Right? But just put it between the right two integers. Between 0 and negative 1. Regions. Okay, regions is the hard part. You're like, where do I put my graph? I said 1 point per branch. I see 6 regions. Which region do you put it in? Okay, make a table over here. And we're going to put the asymptote here. Leave space, and we're just going to say left. Left of the first vertical asymptote. Negative 3 is right here. To the left, I have 2 regions on top of each other. This has to be a function, which means I have to pick one of them. 6 regions, I need to pick 3 of them. Left, middle, right. Now the outside sections, they're going to look like the parent. But where do I put it? Okay, so I want you to put equals 2 over x minus 3, x plus 3. Because I want the function close to where I'm doing this. This is the high level part, okay? The double asymptotes and how do you pick regions when you actually have to make a choice? It's a little bit tricky. Okay. What's a number to the left of negative 3? Negative 4. Okay, question. No, didn't I already tell you that? Dude, you gotta listen at the beginning of class. I already told you what's gonna be on the quiz. Okay? Now, can you be a little closer to the asymptote than negative 4? Okay, negative 3.5. Can you be a little closer? Yeah, I like negative 3.1 a little better. Okay. Negative 3.1. We're going a little bit concrete here. Now, when you have an vertical asymptote, the arrow is either going to go straight up or straight down. Okay? When you have, this is what we're choosing between. Okay? We need to know whether the graph is going to go like this or whether the graph is going to do this. I'm trying to decide between the two pieces. It's one of them. Look at your vertical asymptote. The arrow either goes up or the arrow goes down. That means that the y value is either positive or the y value is negative. That is what I'm choosing between. Now, I don't want to be too far away from my asymptote because you might get a false positive answer. Okay? I want to be really close to my asymptote. Now, what's happening? Okay? Negative, plug it in. Tell me what you get. 2. Let's try this one. Okay. 2. None of these work. Sorry, guys. Okay. There we go. So 2 over. Okay, when you plug in negative 3.1, you get negative. I don't really care, guys. I just want the sign. You get negative 6.1. Okay? When I plug in negative 3.1 to this factor, I get negative. Okay, what's 2 divided by negative times negative? Is it positive or is it negative? Positive. Oh, that means that I have to choose this one. That means that you have to choose the top one because the arrow has to point up. That's how you pick your region. It's called a sign chart. You're just comparing the positives and negatives to figure out that the arrow was supposed to point up. Well, if the arrow goes up, that's as good as a point. It means put it in the top left section. And then you draw the shape. Do I need points? Not really. Not really. The arrow is a point. The arrow is a point. Once you get your asymptotes, okay, asymptotes, intercepts, regions. The only points I'm really going to grade are the intercepts. Any other points you put on the graph are for you. I prefer you do regions, which is a sign chart. Plus minuses to figure out where it goes.
So when you get the negative 3.1 and the negative 3.
The negative 3 is my vertical asymptote, so it tells me that I'm to the left of my first asymptote. I'm just keeping track of where my regions are.
And then it's 3.1 just like C.
Yep, because this is the first time you do a really abstract concept, so I'm putting a concrete number there to help us figure out whether it's positive or negative. Okay, there's my asymptote, so this is my first region. Okay, let's do the second region. Okay, my second region. That's right here. Let's go to the right of this asymptote. So that would be, okay, number line. Pick a number to the right of that asymptote. 2.9. Yeah, I like it. 2.9. Okay. Positives and negatives. 2 over. Oh. Okay, when I plug in negative 2.9, the first factor is negative, the second factor is positive. So what do you get when you divide that up? You get a negative number. That means the arrow has to point down. Has to be down. That's what this means. It means next to the asymptote, just barely on the right of it, the arrow points down. Okay, there's my other asymptote. Right, 3 sections here. 1, 2, 3. In between the asymptotes.
So
Yeah.
why do you just
1 second, Ben. Yeah.
Would this be a negative parabola?
It is going to look like a negative parabola type shape. I say parabolic.
It doesn't touch the.
Yeah, because look, I've got an arrow and a point, so I'm going to connect them. Connect your arrow and your point. Now, when I'm looking at this, can my arrow go up or down? It has to go down because you cannot touch the x-intercepts because you already told me there aren't any. And so I'm going to do positive 2.9 just to be sure. So I get negative times positive, so that's negative, means my arrow points down. Okay, let's do the next region. You decide. You try to figure out whether this right region is going to be up or down.
By adding 2.9, do you get positive and positive?
Oh, I got 2.9 is negative,
Negative.
positive. So the combination is negative, which is good because it's supposed to be down. Okay, you decide. Top right section or bottom right section. Do a sign chart and figure it out. Third section, you can try positive 3.1. Plug in 3.1 and see what you would get. Guys, graphing is a no calculator skill. That's why we're estimating instead of plugging and chugging points. It's very slow. You can't count on
Victory Royale.
Okay, so instead
So would that be pushed back this one like that, right? So both
classes just about over.
It's a negative and a negative. That's shallow. Negative times negative.
So you can't be doing it everywhere else. So why?
Okay, you get top right. Top right.
Is that his female name?
No, I mean like you know what that term
I'm gonna keep it real with you. I'm gonna keep it real with you. You know, like, go to
Hey, what did you get your car insurance?
Okay, I'm going to show you one thing